Okay, everybody, welcome back from vacation. Time for Chapter 7. The first part of Chapter 7 is actually pretty easy, relatively speaking, and it is review of stuff you did last year. So you should have note page 94 out. And but before we write anything down, we're just going to talk a little bit of theory here. So we know how positive exponents work. That's what this section's about, both positive and negative exponents, right? So we know that, like, if we have 3 squared, that's 3 times 3 equals 9. But do you remember what happens when we have those negative exponents or zero exponents? So if we think about what's happening here with this table, you can see that every time we're dropping down by a power, we're dividing by 5. So 3,125 divided by 5, and then we divide by 5 again, right? And every time we drop down a power, we're dividing by 5. So that means that if to go from 5 to the first to 5 to the 0, we would have to divide by 5, which gives us 1. Did you remember that rule that any power raised to the 0 is actually 1? Any number to the 0 power equals 1. I think we'll write that down again later, so you don't have to write it down quite yet. And then we're going to keep dividing by 5 every time we're dividing by 5. So now we have 1 divided by 5 is 1/5. And then we divide that by 5 again, right? And what we end up with is 1/25. And that's kind of interesting, right? Because it's starting to look like the same pattern going back the other direction, right? With the denominators getting bigger every time. So let's review those little rules, right? That basically what happens here when we have 0 exponent, we get 1 every time. Negative exponent, do you remember this? It pushes it into the denominator, but the exponent flips the sign. So 5 to the negative first is the same as 1 over 5 to the positive first power. 5 to the negative second is the same thing as 1 over 5 to the positive second. And don't forget that exponents only belong to what they're right next door to. Base and exponent, you better remember that. Okay. Now, integer exponents. You're going to fill this into the chart. This goes on the top line of the chart, right there below where it says integer exponents, P394. You're going to fill that in words. Okay. Any non-zero number raised to the 0 power is 1. Write down an example with numbers. You don't have to write them all down, but at least one, and write it down algebraically. If you need to pause the video, go ahead and pause it, but I'm going to save time by scooting along. The rest of the chart gets filled in with this. Now this is a little bit wordy here for negative exponents, so you certainly abbreviate. You don't need to write the whole word negative out. But it is important to get the idea here that a negative exponent is equal to 1 divided by that number raised to the opposite exponent. Okay, and then you've got your numeric examples, and you have an algebraic example. Okay, so I always think about it kind of like if you're negative and you're upstairs, then you're going to come downstairs and be happier. Like it's a 2-story house. Right, so if you're upstairs, you come downstairs, and we'll look at what happens if you're unhappy downstairs, meaning you have a negative exponent in the denominator. What happens? We'll look at that in just a moment. Okay. Now you'll notice, you don't have to write this down, this is just FYI, you'll notice that in the definitions it said non-zero number. And that's because 0 raised to the 0 power, 0 raised to a negative power are both undefined. You can't raise 0 to the 0 power, and you can't raise it to a negative power because that would essentially make you at some point be dividing by 0, and so that doesn't work. Okay, so no zeros. So let's try a few. There's 4 here. Do the first one with me, and then you can try the other 3 on your own and come back and check the answers. Simplifying here does mean that you will multiply it out unless it's enormously difficult. Okay, so 1 over 4 to the third is 1 over 4 times 4 times 4. You don't have to write that part down. You can just skip right to the answer, which is 1 over 64. 7 to the 0 power, please don't write 7. Write 1. All right. Try this one, maybe on your own if you're feeling brave. Okay, remember the negative is in the parentheses, so we're going to push it into the denominator. The 5 stays negative. The base doesn't change. If it's negative, it stays negative. Right? It's the exponent who changes. And then negative 5 times negative 5 times negative 5. So that's negative 5 times negative 5. Let's jot it down. So that's 25 times 25. And those are both positive. And 25 times 25 is 625. So that's our final answer. Now D is a little bit different. Be careful. Do you remember how the exponent only belongs to what it's right next door to? So this problem is really 1, negative 1 times 5 to the negative 4th power. So we already know what 5 to the negative 4th power is. It's 1 over 625. Since we have to multiply it by negative 1, it ends up being negative, even though the power is even. Okay, that negative's out front. Okay, so that's just a reminder of what we were just talking about. Okay, there's not a lot of room on this page for a lot of extra stuff, so squeeze those examples in or get a piece of binder paper. Okay. Some of the problems you're going to do, you're going to have variable instead of a number given, but then we're just giving you a number to plug in, right? So this is not any different than the previous set of problems. I'm just reminding you. Ooh, now we get to ones that are a little bit trickier. Oh, jot the problem down. Negative 2, a to the 0 power, b to the negative 4th power. And a equals 5, b equals negative 3. And we're going to evaluate this. I don't know why my color thing keeps staying up there. So plug everything in. Negative 2 times 5 to the 0 power times b, times negative 3 to the negative 4th power. When we evaluate and simplify these, we want to do as much as we can to make it as simple as possible. So the negative 2 stays there. 5 to the 0, that's 1. Negative 3 to the negative 4th power. Well, so that's 1 over negative 3 to the positive 4th power. And that's going to be 3 times 3 times 3, 4 threes is 81. And it doesn't matter that they're negative because it's all going to multiply out. So we end up with negative 2 on the top. And remember, all these have 1s on the bottom. So negative 2 on the top and positive 81 on the bottom. And that can't be simplified any further, so I'm done with it. Okay. Moving on. I think this is going to go in the chart there at the bottom, simplifying expressions with negative exponents. What if there's a negative exponent in the denominator? Well, we know that if we have a negative exponent in the numerator, like this one right here, right, that then it pushes down into the denominator and becomes positive, right? Which means that, right, if it was positive downstairs, it's negative upstairs. Okay? And so then we can take that conjecture and we can extend it. And we can say, well, so if n just happened to be negative, like let's say n was negative 8, the way it is here, I'd get the negative of a negative, which is, of course, positive. So let's go back to our idea of the two-story house. Here's your house. Right? This is the numerator, and this is the denominator. If you are unhappy upstairs, you go downstairs, and then you're happy. If you are unhappy downstairs, then you go upstairs, and you are happy. Right? Unhappy meaning negative, happy meaning positive. So when you change levels of the fraction, you flip the sign on the exponent. Okay? So find a way in your own words to jot that down, right, for negative exponent in the numerator and for a negative exponent in the denominator. I want to see those ones filled in. Right? You can use what I've got written here at the bottom to help you. We're going to do a little more simplifying. These problems are short, so you should be able to squeeze them down there on the bottom of page 94. Simplify. This means that all the exponents should be positive. Now remember, exponents only belong to what they're right next door to. So this is 7 times w to the negative 4th power. The 7 does not have a negative power. If you want to think of it as having a power, it would have a positive 1. So it's only the w to the negative 4th that moves downstairs and becomes happy, positive 4 power. Okay. Negative 5, that's to the 1st power. It's not the base that we're concerned about being negative, it's the exponent. And then k to the negative 2nd, it's not very happy downstairs, so it's going to move upstairs. The 5 stays upstairs too, and we get negative 5k to the 2nd power. Let's try another one. Once again, we're simplifying. Go ahead and give it a try yourself as you copy it down. See if you can get everybody into their happy spots. If I'm going too fast for you, go ahead and pause it, but I'm going to talk through it now. A to the 0, well, that's just 1. Let's get rid of that. B to the negative 2nd, right? It wants to go downstairs so that it can be b to the positive 2nd where it's happy. And c to the negative 3rd, it wants to go upstairs, so it'll be happy. And d to the 6th, it's already happy, so it stays downstairs. And that's it. And the a to the 0 is gone because it's just 1. And 1 times c to the 3rd is just c to the 3rd. This is kind of fun, huh? So little arithmetic. And, wow, that's it. Can you believe it? Done already.